Okay, hello everyone. Lesson is about continuous function. So here is the definition. It starts with, the definition says that a continuous function is a function does not that does not have discontinuities, any which means any unpredictable variation in value. Now, if a function can be drawn without lifting the pen from a drawing plane, it is a continuous function. So an example for this one is, say if we draw the graph of the function and we draw it this way. So see that when I draw the graph, I did not lift the pen, or I did not lift my pen. But say we have this one here, the example that we did then on in the graph of 1 over x, you see that the graph goes this way. In the first quadrant, it looks like this one. Then we have this one. So for you to draw the graph of this second function, or the graph of 1 over x, we lifted the pen. So that's the difference between lifting a pen and not lifting the pen. Now, but besides, this is just to show you. This is just simply showing you by doing the graph. But if we want to know, or there is actually a condition for a function to be continuous, and there are three of them, conditions. So we say that a function f of x is said to be continuous at x equals c if the following conditions are satisfied. Now, the first condition says that the function is defined at x equals c, which means that when you solve for f of x, or given f of x, if you substitute c for x, f of c must be defined. You should get a value for f of c. Now, the next one is if the two-sided limit exists. That is when the limit coming from the right is equal to the limit coming from the left. That's the second condition. Now, the third is that the two-sided limit and f of c must be equal. So we have three conditions. This one is the first condition, the second, and the third. Now, for the function to be continuous, all of the three conditions must be satisfied. Now, if any one of these three conditions fail to hold or is not satisfied, then the function is said to be discontinuous at x equals c. So let's go over this first example here. We're asked to, given the function, which is a piecewise defined function, given f of x, and there are 4 rules of association. You have 1, 2, 3, 4. You're asked to determine if the function is continuous at x equals -2, 1, and 2. Okay, so let's start first with x equals 2. Alright, so if x equals 2, if x is -2, that's the first one, hold on. X is -2, okay. So what is the first condition? So the first condition is that f of c must exist. So we have to solve for f, which one must be used as f of x, because it says x equals -2. So x equals -2 here, right? X is less than or equal to -2. So we use x equals, or f of x equals x plus 4. So if we solve for f of -2, that's -2 plus 4. And that gives you +2. Alright? Now, the next condition is that you should have what? So by the way, the first condition is satisfied. So therefore, you say that this is satisfied. Why is it satisfied? Because we get a value for f of -2. Now, the second condition is that the two-sided limit must exist. So it means that you need to solve for the limit of f of x as x approaches -2 coming from the right. So if you come from the right of negative 2, so let's draw the real number line with using negative 2. So if this is negative 2, if you come from the right of negative 2, we say that here x is what? X is greater than negative 2 or equal to negative 2. So which of the rule of association will you use here for x to be equal to negative 2? Sorry, for x to be greater than negative 2. So which of these gives you x greater than negative 2? It's this one. It's this one here, right? This one here. Kasi you write this as what? Negative 2 is less than x. But remember, when we discuss inequality in algebra, if we change position, this becomes what? If you put here negative 2, this becomes what? X is greater than negative 2. Hold on. X is what? We put here x, we put here negative 2, less becomes greater. So x is greater than negative 2. That means x is greater than negative 2. So if you come from the right of negative 2, x must be greater than negative 2. So we'll be using which one? X squared minus 2 for f of x. So we find the limit of our f of x is x squared minus 2. That is as x approaches negative 2 coming from the right. So to evaluate this one, we substitute negative 2 for x. Minus 2. And that gives you 4 minus 2. You also get 2. Right? Now, you also have to solve for the limit of the function. The limit of, let me change the color. Let's solve for the limit of the function f of x, this time as x approaches negative 2 coming from the left. So if you come from the left of negative 2, this is negative 2 coming from the left, this is the region, right? This one here. So therefore, this means that x here is what? Less than negative 2. So in this region, we say that x is less than negative 2. If you come from the left of negative 2, x is less than negative 2. So which of these will you use? Which one is less than negative 2? X is less than negative 2. Less than or equal to negative 2. So it's this one. Diba? Ito din. Because this says x is less than or equal to negative 2. Alright, so we have here to use x plus 4. So for letter C, hold on, we use here the limit of x plus 4 as x approaches negative 2 coming from the left. Alright, so that will give you, substitute negative 2 for x, it gives you 2. So what do you say about the two-sided limit? So we conclude, therefore, we say that the limit of f of x as x approaches negative 2 exists and is equal to what? 2. So the two-sided limit exists. That's the second condition. So we say that the second condition is satisfied. Now, what's the third condition? So for letter C, we should have letter C. For letter C, we should have what? F of C must be equal to the limit or the two-sided limit. So, what is our F? So, we say that since F of C, sorry, let's use F of negative 2, then F of negative 2 is equal to the limit of F of x as x approaches negative 2, okay? So f of negative 2 is equal to what? 2. The limit of the function, or the two-sided limit, is also 2. So they are equal. So we say therefore that the third condition, this third condition here, is satisfied. So since all of them, the first, second, and third condition, are satisfied, then we conclude therefore, let's write the conclusion here. So our conclusion is that, we'll just simply say that, therefore we say that f of x is what? Continuous at x equals -2. Alright, so that is where at x equals -2. Now we're also asked to solve for, to check if it's continuous at x equals 1. Okay, so at x equals 1. So again, for letter A, we need to find which one? We find f of x. So decide first which one will you use as your f of x. So it says here what? At x equals 1. So when is x equals 1? It's here. X equals 1 here. So we say that we use what? F of x is equal to 3x minus 4. Alright, so if you want to solve for f of 1 is 3 times 1 minus 4, and that gives you -1. So we say that the first condition is satisfied because f of 1 exists and is equal to -1. Now for letter B, we need to solve for the limit of f of x as x approaches 1 coming from the right, and also the limit of f of x as x approaches 1 coming from the left. So if you come from the right, which of the function will you use here? Coming from the right of 1. Okay, hold on. Let's write it down here. It will be coming from the right of 1. This is your 1 coming from the right of 1. Then this region is the region which is what? Less than 1. I'm sorry, greater than 1. This is the region greater than 1. So which will you choose here? Which is the one which is greater than 1? It is equal to what? 3x minus 4. Kasi dito here, we also have x is greater than or equal to 1. Again, if you're going to reverse, 1 is less than or equal to x. If you put here x, put here 1, it becomes greater than or equal to 1. So x is greater than 1 when f of x is what? 3x minus 4. So you'll be using here 3x. Hold on, you'll be using here what? It's too big, hold on. You'll be using here 3x minus 1. Tama ba? 3x minus 4, sorry. You'll use here 3x minus 4. Okay, so as x approaches 1 coming from the right, so that's 3 times 1 minus 4. That gives you 3 minus 4, which is -1. Now we need to solve for the limit coming from the left of 1. So if you come from the left of 1, if this is 1 coming from the left, that's this region, and this is when x is what? Less than 1. So which of this function is less than 1? X is less than 1 when what? Here, x is less than 1 when f of x is x squared minus 2. So we have to use here, we'll have to substitute x squared minus 2 for f of x. That's as x approaches 1 coming from the left. So you'll have here 1 squared minus 2 is equal to 1 minus 2, which is -1. So we say that the right and left limit are the same. They are both -1. So what's our conclusion for letter C? So our conclusion is that we say therefore that since f of 1 is equal to the limit of f of x as x approaches 1, which are both equal to -1, then we conclude therefore that f of x is what? Continuous at x equals 1. Alright? Now, the next is to check or to determine if it's continuous at x equals 2. So at x equals 2, again, which must be your f of x? Well, let's use a different color for this one. Which one do we use as our f of x? When is x equal to 2? When is x equal to 2? That's this one. Right? So, we have f of x must be equal to what? 1 over 8 of x cubed plus 1. So, if you solve for f of 2, that will give you 1 over 8 times 2 cubed plus 1. And that gives you 2 cubed is 8 over 8 is 1 plus 1. That gives you 2. So again, since you get a value for f of 2, then the first condition is satisfied. Alright? Now, this is the first condition. Hold on. Now, what's the second condition? The limit of the function f of x as x approaches 2 coming from the right must be equal to the limit of f of x as x approaches 2 coming from the left. So, if you come from the right of 2, so if this is 2 coming from the right, it's this region. And we say that this is x is greater than 2. So, which of the rule of association will you use? When is x greater than 2? So, x is greater than 2 when you have what? X is greater than 2 when you have 8x cubed plus 1. So, we'll use here 1 over 8. Okay, hold on. We have to write it first. We need to find the limit of 1 over 8. Hold on. 1 over 8 of x cubed plus 1 as x approaches 2 coming from the right. So, that will give you 1 over 8 times 2 cubed plus 1. And that gives you 2 also. Alright? Now, we need to solve for the limit coming from the left of 2. So, if you come from the left of 2, if this is 2 coming from the left, this is the region which is what? Less than 2. So, which one of the function here is less than 2? Which one here is less than 2? So, that is what? This one. Less than 2. This one is greater, this one is less than 2. So, we use here 3x minus 4. So, therefore, we use here, you find the limit of 3x minus 4 as x approaches 2. So, we substitute 2. So, 3 times 2 minus 4 is 6 minus 4. It gives you 2. So, since the right and left limit are equal, then we conclude that what? We have therefore the limit of f of x as x approaches 2 exists and is equal to what? 2. So, the two-sided limit exists. So, what's letter C? We need to show that what? F of 2 must be equal to the limit of f of x as x approaches 2. And they are the same. They are both equal to 2. Right? So, we say therefore that since f of 2 and the limit of f of x as x approaches 2 are equal, then we conclude therefore that f of x is what? Continuous at x equals 2. Alright? Okay, so the next is, so we were able to show that what? we have the graph is continuous at the points what? X equals -2, 1, and 2. Now, besides showing that the function is continuous, by showing that the three conditions are satisfied, then we can also draw the graph of the function. So how will you draw? This is the resulting graph of the function. So how do we draw this graph? You should know how to do it. Like for x plus 4, how do we get this red line here? So this is what you do. Actually, you know that the graph of x plus 4 is what? A straight line. So what we do is we simply what? So we draw the graph of x plus 4. If f of x is x plus 4, what do? We substitute values for x and we solve for y. And remember, from this given condition, when f of x is x plus 4, that is the region when what? X is less than or equal to -2. So it means you start here with -2, then -3, -4, and so on here. But you don't go beyond. You don't go beyond this region because it says that it is less than or equal to -2. So when x is -2, what is your y? You have 2. -3, this is 1. -4, this is 0. -5, this is -1. So if you're going to draw the graph here, look. When x is -2, your y is +2. So this is -2, +2. And then when x is -3, you have +1. When x is -4, it's 0. When -5, it's -1. So this is the line. You have this as the graph of x plus 4. Now, how will you draw x squared minus 2? So look, pwede rin ang point plotting system. But you know that if you have x squared minus 2, this is a parabola. Okay? So let's have, when f of x, let's use a different color for this one. When f of x is equal to x squared minus 2. Now you know that we could write this as what? Y is x squared minus 2. And that we could have here, we could change this into x squared, transpose this here, is y plus 2. And we say here that the vertex is at 0, -2. And it opens up. So look at this one. This is your parabola. The vertex is at 0, -2 here. This is your vertex. And it opens up. Now again, you have to solve for other points here. So you can also solve for this one, for the x-intercept. Alright? But what you do is, as I've mentioned, you can do what? Point plotting system. You substitute values for x and solve for y. And what will you substitute for x? It should be what? In between -2 and 1. So the first one here is that it's greater than -2 but less than 1. So greater than -2, then you have here -1, 0, 1. So ito lang yung numbers natin. It should be greater than -2 but less than 1. Okay. When x is -2, what is your y? You have 2, right? And that's this one, 0, -2. Now, when x is -1, what is your y? When x is -1, -1 square minus 2. So, it's 1 minus 2. That gives you what? -1. So, when x is -1, okay, if we plot, okay, hold on. Let's have 0 first. When x is 0, y is -2. Remember, you're doing this one. When x is 0, y is -2. When x is 1, y is -1. So, we're going to look at the graph here. When x is 0, negative 2, that's the vertex. Then when x is negative 1, your y is negative 1. When x is negative 2, when x is negative 2, your y is positive 2. Ito. Then, when x is 1, y is negative 1. Alright? And so on. So, do the same thing for 3x minus 4. Do the same thing for this one. And for this one here. And you have this is the graph of your function. Okay, so that's how you draw the graph. Do point plotting system and use this values of x, which is to be substituted for x. Alright, so based on this graph, you can see again that the function is continuous. Okay, now let's go over the next example. Now the next example gives us this again is a what? Is a piecewise defined function. Now, again we have here how many rules of association? We have 3. You're given the function y, whose rule is x squared plus 2, it's also ax plus b, and this one on different intervals, on different x intervals, or on different values of x. Okay, now the question here is for you to determine the values of a and b. With what? The function being continuous. So for continuous function, remember you have 3. Pero out of the 3, the first one is to have your f of c be defined. And the next one is that the limit coming from the right and left of the number must exist. So it's for this one, you have to use the second condition. Because if you use the second condition, you'll have two, if you use the second condition, you'll have 2 equations. If you'll be using the first one, you don't have, you only have 1 equation. So for this one, we use the second condition, which is what? Finding if the two-sided limit exists. So, for the first one, we want to find a and b. So, let's solve first for a. Right, so, if we want to find a, what we do is we have to find what? The limit of the function, okay, the limit of y as x approaches which number? Now, take note that you only have 2 numbers here, 0 and 1. 0 and 1. So, you'll be looking for the limit of the function as x approaches 0 coming from the right, and the limit of y as x approaches 0 coming from the left. So, if you'll be coming from the right of 1, which of the function here will you use? Which of the rule of association will you use? So you'll be coming from the right of 0. Hold on, let's use a different color. You'll be coming from the right of 0. So if this is 0, coming from the right, this is the region which is what? X is less than 0. And which of this rule of association is less than 0? That's this one, right? X is less than 0 when y is what? X squared plus 2. So, we find the limit of what is your y? X squared plus 2. And that is as x approaches 0 coming from the right. So, if you substitute 0, 0 plus 2 is equal to 2. Right? So, that is what? The limit of y as x approaches 0 coming from the left. Now, from the right. Now, let's solve for the limit of the function as x approaches 0 coming from the left. Now, take note that if you'll be coming from the left of 0, these are your numbers. And this is what? Less than 0. So, which of these is less than 0? Which function? Sorry. This is less than 0. Hold on. I did something wrong on the first one. Why? This should be what? There's something wrong with this one. Let's revise. This should be what? X is greater than 0. Okay? So, if it's greater than 0, So we have to erase this one. Hold on. Okay. If it's greater than 0, kasi coming from the right of 0. If it's greater than 0, we'll be using which one? This one here. Right, hold on. We'll be using this one. That's the one which is greater than 0. Okay, sorry for that mistake. Anyway, so this means that what? Kasi we could write this as what? 0 is less than or equal to x. Put x here, put 0 here, it becomes greater than. Alright, so we must be using here which one? There's something wrong with this. We should use here. Let's revise this. F of x here must be what? 2ax plus b. Alright? So if you want to find the limit of 2ax plus b, we substitute 0 for what? For x. And so we get here b. Alright? So the limit of the function as x approaches, the limit of y as x approaches 0 coming from the right is b. Now, we solve for the limit coming from the left. So if it comes from the left, what should be your y? So that is the region which is what? Less than 0. So we'll be using this one. Less than 0. So we'll be using this function. So we substitute here x squared plus 2 as x approaches 0 coming from the left. If you substitute 0 for x, 0 squared plus 2, or we just simply have 0 plus 2. Alright? Now, our condition for the function to be continuous is that the two-sided limit must exist. So for the two-sided limit to exist, we should have what? The limit of y as x approaches 0 coming from the right must be equal to the limit of y as x approaches 0 coming from the left. And coming from the right, you have there b. Coming from the left, you have there 2. So we say that b equals 2. Alright? So we already have a value for b. But we need also to solve for the limit of, we need also to solve for a. So how do we solve for a? So this time, as I've mentioned, you only have two numbers here, 0 and 1. So we can use the other number 1. This time, we find the limit of the function as x approaches 1 coming from the right and left. Okay, so we have this one here. Okay, so we need to find, so a, b, so we have, let's have here at x equals 0. Now, for the next one, we have at x equals 1. So what's letter A? We need to find the limit of y as x approaches 1 coming from the right, and what? The limit of y as x approaches 1 coming from the left. So if you come from the right of 1, so if this is 1 coming from the right of 1, this number, this region is x is what? Greater than 1. So if it's greater than 1, which one here is greater than 1? What will you use for, what will you substitute for y? This one is greater than 1. Right? So therefore, we have here the limit of 3 plus 2x minus x squared as x approaches 1 coming from the right. And if you substitute 1, we have here what? We'll have here 3 plus 2 times 1 minus 1 square. That gives you 3 plus 2 minus 1. That gives you 5 minus 1 is 4. Alright? Hold on. Okay, next is we solve for what? We have here the limit of the function coming from the right of 1. This time we want to find the limit of the function as x approaches 1 coming from the left. So if you come from the left of 1, it's this region here. And this is less than 1. So which of this is less than 1? It's this one here, which is 2ax plus b. So we put here, we substitute 2ax plus b for y as x approaches 1 coming from the left. And then we substitute what? 1 for what? 1 for x. So 2a plus b. So this is equal to what? 2a plus b. And we know already that b is what? From the previous, we have b is equal to 2. So it's 2a plus 2. That's the limit of y as x approaches 1 coming from the left. Or we may just first write here, ito lang muna. Okay, so this is the limit coming from the left. This is the limit coming from the right. So what do? We equate the two. So 2a plus b must be equal to 4. And we know that b is 2. So from here, we have 2a is 4 minus 2 is 2. We get a equals 1. So therefore, we have a is 1 and what? B is 2. Okay? Alright, so that's our second example. Now, again, we can draw the graph of the function, knowing the values of a and b. Alright? And this is the resulting graph. Okay, now the next one is how if we have, kasi yung una, the discussion that we have is a continuous function. How if we have this continuous function? When are we gonna have this continuous function? Okay, so hold on a second. It's getting too hot. Okay, so look at this example here. Okay, we have the first few examples that we did shows functions which are continuous. Now, how about this continuous function? Now, look at this. We have studied this graph already. Last time, in our discussion on limits, we discussed, or we showed, or we interpret this graph also. Now, from this graph, you could see that on the interval wherein x is less than -1. So where is that region? If you're going to look at this graph here, this is the region which is what? Less than -1. It's on this side, on this region, right? And you can see that the graph of this function, of the green function here, is continuous. Diba? It's continuous. So continuous on this region, right? Up to -1. Now, the next one is on the interval greater than -1 but less than -1/2. So this is the region this is the region greater than -1 but less than 1/2. This one here, right? So you can see again that the graph on this region is what? Is continuous. Same on the region when x is greater than -1/2 but less than 1. So, greater than -1/2, it's this region here, but less than 1. So, you could see that this graph here is continuous, right? Then also, on the region greater than 1, so that's this region here. This is the region greater than 1. It's continuous, right? But it says that it is discontinuous at x equals -1. Where is x equals -1? Ito. That's this point here. When x is -1, you have here an open circle. So it means that it is discontinuous because it's an open circle. There is no value for y. Okay? Then on x equals -1/2, you could see here, okay, at this point again, this is the value when x is -1/2. This is your graph, or that's the point. And you again have here an open circle, which means that the graph is discontinuous at this point. Now, the next one is this one here. So look, this is also discontinuous. The graph is discontinuous at x equals 1 because this again is an open circle. Alright, so if you recall last time we say that, look at this one. Last time we say that if the limit comes from the right, this is 1, right? If you come from the right of 1, okay, what is the limit? It's 0, right? It's this value here, 0. Okay, now, if the limit comes from the, if you find the limit coming from the left of 1, the limit is also 0. So we say that the two-sided limit exists. But f of 1, what is f of 1? It does not exist because there is no point. The point here is not included. It's an open circle. This one is an open circle. Right? So since it's an open circle, then when x equals 1, y does not exist. So therefore, that's why it's discontinuous at x equals 1. Alright? Now, there are different types of discontinuity. The first is removable or whole discontinuity. And this happens when the function, if both the right hand and the left hand limit exist but are not equal. Again, a function is said to be removable. A function is said to be removable, or sometimes we call it as missing point. So, a function has a removable discontinuity or a hole at x equals c if the right hand and left hand limits exist but are not equal. Okay? So, we say that the limit of the function as x approaches c coming from the left and the right exist, but they are not, not equal to f of c, or again. So, a function has a removable discontinuity or a whole discontinuity, or sometimes we call it as a missing point, if the right hand limit and the left hand limit exist, or they are equal, but it's not equal to f of c. So, look at this one. The limit coming from the right and left are both equal to L. But the limit which says that the two-sided limit exists and is equal to L. But L is not equal to f of c. So, this is an example. Look at this graph here. So, we say that this is a removable discontinuity. Why? Because if we want to find what's the limit of the function, let's write it down. What is the limit of your, let's call it f of x, as x approaches 2, coming from the right. This is your x equals 2, right? So, coming from the right of 2, what is your limit? It's equal to 12. It's this 12 here, right? Now, the limit of the function f of x as x approaches 2 coming from the left. So, if you come from the left, the limit of the function is also what? 12. Alright? So, we say that the two-sided limit, or the limit of f of x as x approaches to exist, and that's equal to what? 12. Alright? But, how about f of 2? Does it exist? Yes. But f of 2 is which one? What is your f of 2? So, from the graph, you could see that this point is, what is this point here? This point is the point which is at what? 2 and positive 8. So, when x equals 2, y is what? 8. And it's what? When x equals 2, this is the same color here. When x equals 2, y equals 8, or f of 2 is 8. Because it's what? A closed circle. So, we say that the two-sided limit exists and is equal to 12, but is not equal to f of c. Not equal to f of 2. So, therefore, this is what we call it as a removable discontinuity. Alright? Next, the next type of discontinuity, or we have an example here, sorry. Okay. So, what type of discontinuity is this? It's similar to this one. Pareho lang sila, diba? So, ito na rin yun. We may just, it's x cubed minus 8 over x minus 2. So, I already have solved the discontinuity here. Okay? So, ito na rin yun. Okay, so, this is done already. Okay. We go to the next type. And the next type is jump discontinuity. When we have a jump discontinuity, and we say that a function has a jump discontinuity at x equals 2 if both the right and left limit exist but are not equal. Okay, so the right and left limit exist, but they are not equal. So we call it as jump discontinuity. So look at this graph here. So again, if we find the limit of the function as x approaches 2 coming from the right, okay, the negative 2, sorry. This is your negative 2, right? X is negative 2. Coming from the right of negative 2, what is your limit? It's this one here. It's equal to 6. Coming from the left of negative 2, that's equal to what? Positive 2, right? So 6 and positive 2, they are not equal. So they both exist. The right hand limit, the right hand and the left hand limit exist, but they are not equal. So we say that we call this is discontinuous, and we call this as jump discontinuity. So therefore, we call this as jump discontinuity. Okay. Now, the next one is when we have infinite or asymptotic discontinuity. So as the name implies, if the limit is infinite, then we call it as infinite discontinuity. And this is an example. You can see that the limit coming from the right, so if the limit coming from the right is plus or minus infinity, or the limit coming from the left is plus or minus infinity, then we say that we call it as infinite discontinuity. And that we say here that x equals c is a vertical asymptote. Alright, so this is the graph. This is an example. This graph is an example. So the limit of the function coming from the right of 0 is what? Let's write it down here. What's the limit of your f of x as x? Let's use the function. The function is what? 1 over x squared. So it's this one. So what's the limit of 1 over x squared as x approaches 0 coming from the right? It's positive infinity. And the limit of the same function x is 1 over x squared as x approaches 0 coming from the left is what? Also positive infinity. So we say that the limit, the two-sided limit, which is as x approaches 0, is what? Since both are positive, it's positive infinity. And we call this as what? Infinite discontinuity. Okay? Alright, let's look at this example here. We have, again, by just looking at the graph, we can find or we can determine the limit of the function. Diba? So, in the graph, what is the limit of our function is f sub 2. What is the limit of f sub 2 of x as x approaches negative 2 coming from the left? So, it's your negative 2. It's this one, right? So, coming from the left of negative 2, what's your limit? It's this. This is the graph, right? It goes down. So, it should be what? Negative infinity. Alright? Hold on. Now, if you come from the right, what would be the limit? Coming from the right of 0, you'll be coming from this direction. What happened with the value of your y? It goes up to positive infinity. So, the limit is positive infinity. So, then the next is what is the limit? By the way, what will be how about the limit of f of x as x approaches 2? You have here, this one is what? Coming from the left, coming from the right. One is negative, the other is positive. So what is the two-sided limit? It does not exist because they are of opposite signs. Now, we find the limit of the function as x approaches 3 coming from the right. So where is your 3? This is your x equals 3. So coming from the right of 3, what's your limit? It's positive infinity. Coming from the right of 3, it's positive infinity. This is positive. Hold on. This is positive infinity. How if you come from the left of 3? Or coming from the left of 3, you go down here. So it's what? Negative infinity. So what's our conclusion here? Again, what is the limit of f of x as x approaches 3? The two-sided limit. Again, they are of opposite signs, so it does not exist. Okay, and we say here that x equals to, this x equals to here, and x equals 3 are our what? Vertical asymptote. Okay, so questions on this one? Oh, anyway, you can ask your question when we meet face to face next time. All right, now we have another example here. So determine the type of discontinuity at a given value of x. So at x equals -7, look, this is your -7. So what type of discontinuity is this one? So again, the limit coming from the right of -7 is what? Positive infinity. Coming from the left is negative infinity. So we call this as what? Infinite discontinuity. Okay, what is asked here is the type. Alright? Okay, at x equals -5. So this is your -5. Okay? So what type of discontinuity? Tama, ito ba yung -5? Right. What type of discontinuity do we have at x equals -5? Coming from the right of -5, what happened with your y? Positive infinity. Okay, so coming from the left of -5, although there is no graph shown here, but again, at -5, you have here an infinite limit coming from the right of -5. So we call this as infinite discontinuity. How about at x equals -4? Where is your -4? It's this one, right? So, what is the limit of the function as x approaches -4 coming from the right? Okay, again, coming from the right of -4, ito yung -4. Coming from the right is what? The limit is, if you're going to approximate, kasi this is 10, this is 15, so probably it is at this value here. Say, we have 13. Okay, then coming from the left is the same, right? This is the same point. Okay, so we say that the two-sided limit exists, right? But it's not equal to what? Because this is your what? F of -4. Diba? So, it's not equal. So, we call this as what? We call this as removable. The two-sided limit exists, but it's not equal to f of c. Now, at x equals 0, it's very obvious that at x equals 0, the two-sided limit does not exist. Right? The two-sided limit exists, but they are not equal. So, we call this as what? Jump discontinuity. At x equals 4, again, at x equals 4, you have infinite. Alright? And then, what are the vertical asymptotes here? What are our vertical asymptotes? You have what? X equals -7, X equals, the vertical asymptotes are x equals -7. Here, this one here. This is a vertical asymptote. What else? X equals, ito pa rin, -5. And we also have what? X equals 4. This one here. X equals 4. Okay? Alright. Now, for the next one, we are asked to show why they are discontinuous at x equals 7. -7, ito. Because we just look at the graph, diba? By just looking at the graph, we were able to identify where it is discontinuous. But how do we show it's discontinuous at c equals -7? Okay. So, if you want to solve for f of -7, what is the value of f of -7? How will you solve for f of -7? Kasi when c is -7, f of -7, do you have it here? You have a value for f of -7? It does not exist. Kasi diba, look, when x is -7, it's this one here, right? Oh, what's the value of your y? It's infinite or it does not exist. So, discontinuous na siya kaagad. Diba? Discontinuous na siya. Kasi, f of negative 7 does not exist. And what's the limit of the function as x approaches negative 7 coming from the right? It's what? Positive infinity. Coming from the left, it's negative infinity. So, what type of discontinuity is this? It's infinite. Discontinuity. So, yun yung inano natin kanina, di ba? At x equals negative 7, it is infinite. Discontinuity. Alright. At x equals negative 5. Again, what is f of negative 5? Do we have a value here? When x equals negative, when c is negative 5. Ito, negative 5. So, although it's close here, kasi pwedeng, but we don't have a value here kasi. F of negative 5 is what? Because this is a closed circle. So, let's just say it's 19. Right? But if you're going to look at the green graph, kasi as x approaches negative 5, as you approach negative 5, it's what? The result is infinite. Okay, so f of negative 5 may or may not exist. Kasi pwede siyang it does not exist, or it can also be what? If you approximate, probably, it could also be 19. Right? But what's the limit of the function as x approaches negative 5 coming from the right? Sorry, coming from the left. This is your negative 5 coming from the left. It's what? Positive infinity. Okay, coming from the right, positive infinity rin. So, we call this as what? Infinite discontinuity. Alright? Now, the next is at c equals negative 4. When c is negative 4, asan na yung negative 4? When c is negative 4, let's remove this. Kasi magulo na to. Hold on, sorry. Okay. At c equals negative 4. When c is equal to negative 4. Ito yung x equals negative 4, right? This one here. What's the value of your y? Do we have a value for y? Yes, we have. Kasi, ito yun eh. This is when c is this point is negative 4. What is your y? So, again, let's just approximate kasi probably it's what? Positive 6. Andito kasi 5 somewhere here. Alright? So, when c is negative 4, when c is negative 4, y is, do we have 6? Yeah, 6. Now, what's the limit of the function as x approaches negative 4 coming from the right? It's what? We approximated that it's about what? Dito, anong ginamit natin? About 12. Right? So, eto. When x is equal to, coming from the left of, magulo yung ano natin. Coming from the left of negative 4, the limit is, let's say, it's 12. Coming from the right, it's also 12. Alright? And that our f of negative 4 is 6. So, this is what? How do we call this one? We call this as jump discontinuity. Sana. Jump discontinuity. So, pareho yun ang inano natin dito. At negative 4. The two-sided limit exists, but no, it's removable. Sorry. Mali. It should be removable discontinuity. Again, why is it removable? Because the two-sided limit exists, but it's not equal to f of c. Not equal to f of negative 4. Okay, as x approaches 0, 0 naman, coming from the left, see, what is f of 0? Hi, what is f of 0? Let's say it's 2. Kasi ito yun, no? This is, when x is 0, let's have y is 2. So, f of 0 is 2. Now, what's the limit coming from the right of 0? Coming from the right, it's 0. What's coming from the left? Let's say it's 4. Let's say this is 0, 4. So coming from the left, it's 4. So we say here that the two-sided limit exists, but they are not equal. So we call this as what? Jump discontinuity. Alright, and then when C is 4, what is your f of 4? What is this point here? That's the point 4, 0. So this is 0. Now the limit of the function as x approaches 4 coming from the right, coming from the left, it's negative infinity. Coming from the right, it's positive infinity. So we say that we call this as infinite discontinuity. So that these are the proof of what we concluded here using the graph. Infinite, infinite, removable jump, and infinite. So infinite, infinite, removable jump, and infinite. So they are consistent with the graph, consistent with what we got when we use the graph, simply use the graph, or we use the condition, the three conditions for the limit, for the function to be continuous using this, using these three conditions here, A, B, and C. Alright, now there are other examples here, and these are for you to go and look for these solutions. So may mga answers naman. Alright, so then there's one more discontinuity that I want to discuss with you, and this is we call this as the greatest integer function. So this is different because, remember, if it's just simply like this, you have an absolute value, but this is different. It is like this one, parang there's may paa, right? So for this one, look at this one here. Okay, how will you get the greatest integer value? Because it's the greatest integer value says that this says that it rounds off the real number down to the integer less than the number. So down to the integer less than the number. So dito, the greatest integer value of 0 is 0 kasi this is exactly 0. So it's not anymore decimal. So the greatest integer value of 0 is 0. But how about the greatest integer value of 0.6? Kasi you have 0 here, right? And say this is your 1. So somewhere here is 0.6. So what is the number? Kasi it says round off the real number down. So what is the number less than 0.6 and an integer less than 0.6? So it's 0. Alright, so how about if you have 0.9? It's still 0. So if you have this one and you have 0.9, it's still what? 0. Now look at negative 0.2. For negative 0.2, if this is 0, this is negative 1. So where is negative 0.2? Somewhere here is negative 0.2. And the number less than negative 0.2, yung nasa left niya, is negative 1. Alright, so look at this one. 0.6, ano nasa left niya? 0. Okay? So same thing with negative 0.9. So nasan yung negative 0.9? It's somewhere here, right? That's your negative 0.9. So its greatest integer value is negative 1. Okay? For 1.23, if this is 0, you'll have here 1. So where is 1.23? Somewhere here, right? Let's make a different color. So somewhere here is your 1.23. And the number to the left of 1.23 is 1. So same thing if you have 1.9 somewhere here. So it's still 1 as the greatest integer value. Okay. For negative 5.12. So if this is your negative 5. We have here negative 6. Somewhere here is negative, somewhere here is negative 5.12, right? So, the number to the left of negative 5.12 is negative 6. Same with negative 5.99. So, somewhere here. So, the number to the left of negative 5.99 is negative 6. Alright? Okay, so that ends. Okay, what type of discontinuity is this one? Again, it's what? It's discontinuous. So, sometimes you call it as what? A floor function. Alright, so it says here that this is the last type of discontinuity. Okay, so that ends our lesson for discontinuity lesson. Alright, so bye-bye, and hope you'll understand what was discussed on this topic before we go to derivative.